my name is Danielle Moore and I'm the Recruitment and Retention Coordinator here at the Rubenstein School. Thank you again for attending our virtual Admitted Student Visit Day this morning. We'd now like to show you a few videos about facilities at the Rubenstein School, so please feel free to check out these videos about the Aiken Center, home of the Rubenstein School on UVM's campus, and the Rubenstein Ecosystem Science Lab down at Burlington's waterfront.
Welcome to the Aiken Center, a newly renovated green building at the University of Vermont. Faculty, staff, and students in the Rubenstein School realized that we need to change our building. We needed to represent more of what we do and how we feel about the world. Natural light and natural ventilation actually provide a healthier, more environmentally friendly atmosphere for people to learn and work in. We have triple glazed windows that are very efficient at reducing heat transfer. We have a highly efficient HVAC system, which is heating and cooling the building. It didn't used to be cooled, but yet we're using about 50 to 60% less energy to do it. All the wood that you'll see in this building was cut, processed in Vermont, in fact from our research forest that is FSC certified, which is Forest Stewardship Council certified, which means it's sustainably harvested. It's done in such a way that maintains the forest ecosystem without doing any damage to the other services that the ecosystem provides. Students went out with faculty, selected the trees, helped cut them down, helped bring them through the milling process, all the way to the point where they helped figure out where the wood was going to go. Students still learn because we have 9 species of woods represented in the building, so they'll learn what wood properties are best, how they look, and they continue to learn by working at our research forest, which demonstrates good, sustainable harvesting techniques. It's actually 8 green roofs that are separately monitored so that we can change the plants, change the soil, and statistically look at it and see what plants or soils are best at treating stormwater and minimizing peak flows so we have reduced erosion. We had 40 or 50 students helping us install the green roof last fall. And we feel that this is an important contribution that the university and the school and us as researchers and students can contribute to Vermont, basically, or to the lake. We're developing systems that can reduce contaminants and water flow that go into Lake Champlain. We'll learn from this well-designed experiment what works best, so that we can then make suggestions for other people and do some calculations, like if half the buildings in Burlington had green roofs, how much runoff, how much contaminants will we save going into Lake Champlain? We have to be able to measure the green roof, the water quantity and the water quality coming off of each one of those 8 watersheds. And we actually do that with a tipping bucket system, which basically means all the water from a given watershed comes through here, drains into this bucket. The bucket tips each time it fills and sends a signal to a computer recorded, and we can actually collect water out of these tubes at any time during the process and show the differences between watersheds in water quality and water quantity. So this is the fun part. You can see these areas in between here represent borders between the watersheds. If you look at it carefully, it all flows in different ways so that the water from a watershed goes into a single drain and we can monitor it downstairs. In addition to water quality, one of the important components of a green roof is it provides insulation for the roof. It adds to the insulation, thus making it slightly less expensive and energy intensive to heat and cool a building. We have 72 of these wires up here that monitor the temperature both below the plants, in the soil, in the vegetation, and about a meter above, so that we can actually look at and compare the different watersheds and how well they're insulating, what they're doing to to temperature modulation. We also have 12 soil moisture probes in the different watersheds so that we can look at moisture content of the soil. An important component to research is that you have replication, you have copies of things. Do they both perform the same so that we can statistically analyze the data and actually be confident in the treatment differences? And that's the kind of information that we'll be able to gather from this experiment and then say to the university or to the community, if we were to do that on all these buildings, here's the amount of water reduction, here's the reduced contaminants that'll go into Lake Champlain. You know, we've had students design projects in the beginning of a semester, write a proposal, get funding from the university, install them, and prove that they've reduced water consumption by 20% in the building, all in one semester. The students are learning something that they not only apply, but it's a skill that they learn that they can apply in the future. They don't have to be green building designers to apply it. They could be a leader in many ways, ranging from town politics right up through leaders of their companies or governments or institutions, that thinking in the background, you know, how can I do this in a better way to reduce the impacts on the environment? Most fun part, I think, is that it ain't over. We're continuing now. We have more students all the time. We have interns that work with us throughout the year. We have classes of 30, 40 students continuing to improve the building, but also using the data that we collect so that we could advise other people that are doing the same thing in their buildings. This is rare that a building would have so many sensors and so much data and allow us to learn from the building from now on. We knew this wasn't something that was just cool to do, it was necessary. It had to be done this way. And we all have to strive towards that in the future if we're going to provide a better, cleaner globe for us to live on.